Required to find x and the area of the small circle. Label T and join line D, T and C, T. Angle T equals 90 degrees. Point C and D are tangent to the small circle. Let D, T equals Y, which is equals to C, T. Tangent lines to a circle from the same external point are equal in length. It means that locate center O of the semicircle and label point G. From triangle ACB. Line AG equals the sum of 6 and 12, which is equals to 18. Line AB is equals to 2 times R. It is the diameter of the semicircle. It means that R, the radius of the semicircle, equals 18 divided by 2, which equals 9 units. Let angle CAB be equals to alpha so that from triangle CAB, we find angle alpha using cosine rule, substitute values, and we have that cosine alpha equals 7 divided by 9. Join line TO to form triangle AOE. Angle E equals alpha since AO equals EO, which equals the radius of the semicircle. It means the angle AOE equals 180 degrees minus 2 times alpha. Now from triangle AOB. By trigonometric identity. Cosine 180 degrees minus 2 times alpha equals 2 times the square of cosine alpha minus 1. Substituting value of cosine alpha found earlier, and we have that cosine 180 degrees minus 2 times alpha equals negative 17 divided by 81. Using cosine rule, the square of line AE equals the value shown on the screen. We found earlier that cosine 180 degrees minus 2 times alpha equals negative 17 divided by 81. Substitute all the values obtained and we have that the square of line AE equals 196. But, length of line AE equals the sum of 10 and x. It means that the square of the sum of 10 and x equals 196. Find the square root of the equation and we have that the sum of 10 and x equals the square root of 196, which is equals to 14. Make x the subject of the formula by subtracting 10 from both sides of the equation. Thus we have that x equals 4 units. Let us find the answer to question 2. Locate the center Q of the small inscribed circle and let its radius be r. Join line DO. It signify that line QO equals the radius of the semicircle minus the radius of the small circle r. This result equals to 9 minus r, as shown on the screen. Thus, line GQ equals to R and line GO equals 9 minus 6, which equals to 3. Use Pythagoras theorem as shown for the square of line QO and substitute values. We have that the square of 9 minus R equals the sum of the square of R and the square of 3. Expand bracket and combine like terms and simplify. It means that 72 equals 18 times R. Divide the equation by 18 and we have that R equals 72 divided by 18, which is equals to 4 units. Area of a circle equals the product of pi and the square of R. Thus, area of the small circle equals pi times the square of 4, which equals to 16 times pi square units.